Thanks, Alison. So first of all, good evening, everyone, and thank you, ASEAN FAW Action Plan, for inviting me here. So I'm Sachchit. I represent a company, General Aeronautics. So we are operating in India, and we are mainly into design and manufacturing of agriculture UAVs for a spraying application. So that is our key domain of expertise, which is pesticide spraying for the agriculture use case. So we started back somewhere in 2016, and from there till now, we are focused on the agriculture use case for the drone. So before we move on to the details, so for all the audience, so how the drones which are used for pesticide spraying. What are the key components in the drone? How they look like? So I'll just give a brief about that. So this drone, particular, this is our own drone called Krishak V2. So Krishak means farmer in India. So yeah, so Krishak V2. This is the drone which we are having. So basically, drone has one key component which is for flying. You require a battery, which is an energy source, and you require propeller, which will generate a thrust for drone to hover and fly. So uh, all the drones which we are using is all multicopters. So already you are clear that what is multicopter and what is a fixed wing drone. So what we are producing, all the drones are multicopters. The next part, which is the important part, which is the payload, that is the pesticide and the water mixer, and the spray nozzle. So how you will spray that thing. So these are the four key components for which are required to convert kind of a drone into a spraying drone. Yeah. So first we'll talk about sustainability, like what are the three key areas in terms of Indian context, and also we'll be focusing on agriculture, that what the end user, farmers, and the community as a whole, people are looking at in terms of the sustainability. So on the environmental side, soil conservation is one of the big problem which needs to be addressed. Second is the water management, the scarcity of water, as well as reuse of the water. On economical front, crop protection, that is revenue. So whatever crop has been lost, that is revenue loss for the farmer. And the second one will be the whatever solution which has been created. It will be only be sustainable if it is cost effective. That means cost is not increasing, but it is kind of reducing with time against the output which is provided. Last part is related to social impact. So first is food quality. So MRL is maximum residue level in the crop. So there are standards across the globe, different countries and different region has different standard. So in Indian context, there are a lot of regions where MRL standards are not maintained, and for the overall society, that is not the right thing to have. So we want to have technology which will allow to reduce this MRL level into the final output, which is the food which people are consuming. And last one is the working condition for the person who is working on the farm. So one is farmer, but there are a lot of people involved around the ecosystem who make sure that crop reaches to the end user or end customer. So safe working condition for all of those things. Uh, the technology or the idea which we are proposing should help in do that. So this is the overall of what sustainability means in terms of agriculture, and kind of what we are looking at is whatever technologies we are developing here in India, we should try to solve for these problems. So first I'll come for the environmental aspect. So how drones is helping in each of this aspect, and how it is improving each of this aspect in terms of sustainability. So first thing, uh, there has been various research which has been published till now. I have cited only one of them here. That when we spray using drones, we can reduce the usage of pesticide by around 20 to 30%. Okay. When I say we can reduce the pesticide usage by 20 to 30%, what I meant to say, like if you want to maintain the same output, that is same yield of the crop, we can use lesser pesticide to achieve the same output. So there are various reasons for that, but one of the key reason which is there or which is more applicable in Indian context is that in India, traditionally spraying is done using knapsack sprayer. So that is like a backpack sprayer. One person goes into the field and sprays the area. So how it works is, if there is a 1 acre area, you want to spray the 1 acre area, you will mix approximately 1 bottle of pesticide into 150 to 200 liters of water, and then that person will start spraying in that area. So for a normal human person, it's very difficult to spray uniformly. So generally, what happens is that the person started spraying. By the end, only say 0.25 acre is remaining, but water remaining is only 20 liters. So there is a lot of uneven spray which goes on. Because of that, there is a chance of a crop damage or say non-effectiveness of pesticide. In that case, farmer generally the only alternate farmer has is to increase the usage of pesticide. So because drones are autonomous, there is no such concern in terms of that the distribution of pesticide will be uneven. So uniformity is achieved using drones. That is a one key area why we are able to reduce the pesticide usage around 20 to 30%. Uh, to showcase that, we have done some study. This is our own study which we have done here in India for different kind of pests. So we are measuring efficacy of a spray using count of the pest remaining after the application of pesticide. So you can see that for all kind of pests, uh, after drone spray, the efficacy is better than the manual spray, which is the traditional method or conventional method which is used here. Coming to water management, so we are using in a drone application, typically you will use 8 to 20 liters per acre rather than using 150 to 200 liter per acre. To achieve this, or say to avoid the phytotoxicity when we are increasing the concentration, uh, drones uses very fine droplet particle size. So you can, I shared some images, you can see clearly that droplet size is very fine. Just few dots of drops will be there onto the plant. Because most of the pesticide which are used here for a lot of the crop is systemic, it can give same effective result. Effectiveness already we have proven that the results are effective. Uh, so this leads to overall saving of around 90% of water usage. So what was earlier around 200 liters is now becoming around 10 liters. Okay. So that's the amount of water saving which end farmer can get. Coming to the economical impact. So first, like there are few crops, specifically tall crops like sugarcane and paddy, where it is very, very difficult to enter into the field when crop is grown already. In case of paddy, because it is flood irrigated, it is very difficult to go inside and spray. For those kind of crops, it is drone is kind of the only solution to spray effectively on those kind of crop. So second thing which we already covered, that it gives a uniform coverage leading to a less chance of less dosage, which allows for crop protection. When I say again crop protection means that yield is not affected. In terms of cost effectiveness, so in India, labor shortage is increasing day by day. The Indian youth is increasingly moving out of agriculture because there is opportunities available in other domains as well. They are moving to those domains. So with that, in a lot of the regions of India, as of now, drone spray cost per acre cost for the farmer and manual spray cost per acre cost for the farmer is almost equivalent. There are also regions where drone spray is cheaper than the manual spray. That is, it is cheaper to rent a drone and cover your area rather than calling one person and asking them to spray. Okay. Uh, this so as of now, people are generally charging around 400 rupees per acre. Whoever is buying the drone, they are providing a service to the end farmer. So that we are calling is VLEs or village level entrepreneurs. Those people, when they buy a drone, within 1.5 year, they are able to recover the capital cost of the drone if they charge 400 rupees per acre, and 400 rupees per acre is sufficient as of now for the VLEs to sustain. Last part, this is just to give you a basic idea. So we talked about reduction in pesticides. So even if the cost reduction is not 20-30%, but let's say only 10% pesticide reduction is done, it is equivalent to approximately 150 to 300 rupees per acre sale. So the point which I wanted to highlight is, if you see the cost which the operator is charging is around 400 rupees. End user can save 150 to 400 rupees just in terms of pesticide reduction. Coming to social impact on the MRL side. So as we discussed, because with drone, we are not doing any overdosage and we are uniformly spraying it. We are able to maintain MRL levels which are required not only in India but across the globe. Not only that, it reduces a lot of the chemical runoff. So when we are spraying 200 liters of pesticide, most of the pesticide goes to the ground, because kind of it will drip from the crop leaf and it will go to the ground. With drone, that is much lesser than the conventional method. So we have done one case study on the cumin. So in that, so there is a belt in India which focuses on export to the EU region. So they struggle a lot to meet the EU requirement for MRL using the conventional method. So once they started using the GA drones, they are kind of 90% below the EU MRL limit, and still the yields are same. So this is one of the study which we have done, which helped the cumin farmer significantly. Last part. So the photo which I am showing here, that is how conventional spraying happens in India as of now. You have to carry around 30 kg of payload on your back, and you will be spraying pesticide. Pesticide will be all over your body, and it is already known this pesticide is pretty harmful for the human if it is exposed in direct contact. So this is the state of spraying as of now. With drone, drone is flying away from you, so you are not coming directly in contact with the pesticide. Not only that, kind of the user only have to use the remote controller. That is the only weight they need to carry. Drone will fly on its own. So that is leads to a lot of reduction in human drudgery, as well as lot of inclusion of women into the agriculture, that they are able to fly the drones. I'll talk more about that how that is helping women in India to fly the drones in the agriculture spraying fields. So I talk about the general trend, how it is working, who is pushing the adoption of drone. So first, like Government of India has announced a scheme last year, which is they will be buying 15,000 agriculture drones from Indian companies under a Namo Drone BD scheme. So all of these drones will be given to the women entrepreneur to provide the spraying services. So this is like one of the key push from the government to adopt drones for the spraying. Second is like government is announced subsidies for all other people to purchase a drone, which is up to 80% of the drone cost. You can claim the subsidy. That means you will be paying for 20% of the cost, and you can buy the drone. Apart from the government push, the early traction from the farmer is coming mainly from the sugarcane field and rice field, as we discussed earlier. There is no alternative to drone in those regions. Only drone is the only way to spray in those regions, and there is a lot of drive from the farmers in this two particular crops. There is also nano products which are popular, or they are becoming popular in India now. So nano products these nano products are not a pesticide, they are mainly fertilizers. So rather than having like 40 kg of urea sprayed into 1 acre, this will reduce it to 1 bottle of urea sprayed into 1 acre. And again, there is only one way to spray nano products into the field, that is using drones. So the companies which are producing these products, which are nano products or nano fertilizers, they are driving the adoption of the drones. Then last part is the cross subsidization by input companies. That means companies which are input provider or pesticide providers, they are subsidizing the end user to buy their product, but use a drone to spray their product. So this is the main driving factor to adopt the drone, or especially the spraying drone in India. So there are a few challenges in terms of drone-based spraying. So first is drift. Drift means like if you are flying above the canopy, and because as we discussed earlier, particles are very fine, due to wind they can drift away. Second, uh, the target area of the drone, the agriculture drone, is in the rural area where education level is much lesser. Most of the people are around 10th grade pass or in that region. And it is very difficult to train them on a complex system. So this is how drone remote control looks like. And flying a drone manually in this region is like very difficult. There's a cluttered environment, a lot of obstacles are there. And this is specifically in India. There are a lot of electricity lines going through the fields, and drones, because of the interference problem, drones generally are not advised to fly near the electricity line. So on in these all three domains, we from General Aeronautics have working from last 2 to 3 years to solve this problem. So some of them are solved, some of them are still ongoing. So for the spray drift, we are working with detailed SOP, that what SOP to be followed with the ICAR labs. So ICAR labs is India's topmost agriculture research labs. And we have came up with SOPs which can be followed, which makes drift acceptable level. This includes tuning of a lot of parameters like what speed drone should fly, at what height you should fly, what should the droplet size of the particle, to ensure drift is at manageable level. Secondly, we have worked a lot on automation. So that starting from the sensors, which will ensure drone automatically avoids obstacle. Also, we have done a lot of work in terms of path planning, because fields in India are of like various shapes. They are not like a proper rectangle or proper square. So we have done a lot of work on path planning so that you can generate a path in any kind of field, so that drone can just follow the path and complete the spraying. And rather than using transmitter, our drones are kind of press to go. So that means you just press a button, it will just complete the task on its own. When pesticide is over, it will automatically come back. You fill up the pesticide, again it will start from the same point. And we have moved away from, so one of the reason why it is not allowed, drones are not allowed to fly near electricity line is a compass. So we have developed a technology and adopted a technology which allowed us to fly without a compass. So our drones can fly below the electricity line as well without any problems. Apart from the technology problems, in terms of adoption, there are two main.
2 minutes. 2 minutes, actually.
Yeah. So mainly two issues are there. One is a high initial cost. So the drone is costing, which is equivalent to the farm equipment, which is pretty high. And second is that farmers are skeptical about the high concentration, that it may damage their crop. In this both the domains, one, for the high initial cost, there's a lot of financing scheme which are coming up and subsidy which is coming up. And in terms of skepticism, government as well as agrochemical companies are doing a lot of work in terms of outreach program to create awareness among farmers that this is not the problem with the drones. In terms of regulations, we have a standard set of regulation in India which is regulated by DGCA. Drone rule has been released in 2021. There are three key things. Every drone pilot should have a license, which takes like 5 to 7 days for a 12th grade person to get a license. All drones require a certification from the DGCA to make sure they are flight worthy. And you can fly only in green zone. So I just put up a photo that almost all of India is green zone, apart from few regions, which is a red zone. Coming to the like what is the future looks like. So overall in India, number of drone requires around 4,75,000 if you want to cover all the regions using a drone-based spraying. The current trend in India is that from 2021 to 2025, it has grown significantly, and it is projected to grow significantly in terms of the drones sold. This is what work we have done in 2022 to 2023, showing all the things which we have covered already to actually prove it onto the field. On the last what we are working on future is to even further reduce the usage of pesticide. We are working on the targeted spraying using heat maps. We have done some work and we have done some trial with very large farming equipment companies, but it is in the earlier stage. Once the technology in terms of detection improves, uh, uh, essentially the pesticide usage for the end farmer will reduce. Also, we are doing some work on the carbon audit using AI for the paddy fields. So this is for a carbon emission which is happening because of not following a particular SOP. So yeah, thank you very much. I'm open for questions.
Thank you so much. That was excellent. And that gives a really good background to what's happening in India as well. And I had lots of questions. You kept on answering them through your presentation. I was like, oh, that's a good question. And you answered it. So really, really nice. And we hadn't actually had a speaker speaking about drones from India before in any of our series. So that was actually really interesting. And there were some questions coming through, but I was really struck by the point of the 15,000 agricultural drones to women in rural areas. That's quite incredible. And so my question is based around that. Are you finding that there's interest amongst women farmers or women to operate drones?
So as of now, already out of those 15,000, 1,100 drones has been given to women, and they're already flying those things. Even we have given around 200 drones which are flown by women now. Yeah.
Oh, that's quite exciting because I've always asked, I'd like to have had a woman drone flyer present in one of our webinars. I found it very difficult to find one. So now I know that I have to go to India possibly to get that. That's fantastic. You talked about the challenges. I was going to ask about the license. So that's quite interesting, that regulatory space as well, because that comes up in a lot of countries. And my question there is, I think you said 5 to 7 days. Do they go to a special school, or who actually trains them and issues the drone license?
So the regulatory body DGCA, they will approve certain agencies to train people and give license to them. So in whole across India, there will be a lot of small agencies. You go there, apply for a training license, and they will train you for 5 to 7 days, and you will get a license after that. Yeah.
Oh, excellent. And I've got a few questions. They're coming in the chat, not in the Q&A, but somebody's asking this question around if 20% less pesticide is used, then are the results compromised? Does it mean that you underdose?
No. So essentially, what I meant is that if you want to maintain the same yield, then you can do away with 20% reduction in pesticide. So some farmers are reducing pesticide usage, some farmers are keeping it same level, and maybe they are getting slightly better result in terms of yield. So it is that study is mainly focused on if you want to maintain the same yield which you are getting with the conventional method. Yeah.
And when the farmers are accessing drones, are they? Is it? Sorry, how does that normally work? Do they just book somebody? I mean, is there so many drone providers that they just look somebody up and somebody comes? Or I think you also mentioned that a farmer could buy one as well. So what's the models that are being used for farmer access?
Yeah, so there are 3 ways generally. So like if you are having a pretty large farm, say 50 acres and above, like kind of you can buy on your own and you can have an economical sense of it. But for most of other people, how it works in India, even for the tractor or any other machinery, that there is one person who is an independent entrepreneur. That person will buy the drone and he will be providing locally service. So you can kind of call him up and get a service. And third one is there are larger agencies like who will buy say 50 drones and they will be providing service. So that will be more like a so we have an application which more like looks like a Uber. You kind of send on WhatsApp a message that I want a booking, and kind of after that there will be a booking flow. So there are all 3 methods are available for the end farmer to book the service.